Good morning. Last day of the conference, last day of the week, the day after Universal, and all of you are here. Thank you so much for joining me. If I do my job right, I'm one of the obstacles between you and the weekend. And I believe that that weekend is going to be filled with Blazor development. We have a lot of different platforms that we as C# developers can reach. We have desktop, mobile, games. We have cloud or server side. We have IoT. And all of these platforms have one thing in common. We can choose any language to develop for. Most of us are probably C. How many of you are C# developers? Oh, awesome. That's good. But we have one more. We have the web browser. And in the web browser, we basically only have one language, JavaScript. OK, I know we have TypeScript that is going to transpile down to JavaScript, but it's still going to be JavaScript's errors that we're going to handle in the end. Personally, I get a warm, fuzzy feeling when I work with JavaScript. I hate you. So we have two options. Either we can all program underwater. Or I'm here to show you something different. We can actually do this with C#. So what we're going to talk about today is, first we're going to talk about WebAssembly. What is WebAssembly? Then we're going to talk about client-side Blazor, server-side Blazor, and then we're going to go into demo time. So we're going to spend the last part of the session in Visual Studio. My name is Jimmy Engström. I'm a Windows Development MVP. I run a company together with my wife called Awesome Dev, focused on future technologies. Future technologies like HoloLens, bots, AI. We even have UX into that category, because with all these new form factors, UX is going to be more important than ever. And later today, Jessica actually has a session about UX, so you should definitely check that out. And now, Blazor. We run a podcast together called Coding After Work, so if you like podcasts, please check that out. But enough about me. Let's talk about WebAssembly. So WebAssembly gave us the ability to compile any language to WebAssembly and run it in our web browser. So what is usually happening is that we're going to download JavaScript. We're going to parse that JavaScript. We're going to compile that JavaScript, and then it's going to run in the JIT compiler. That's the normal case. But with WebAssembly, we're just going to bypass all of this straight into the JIT compiler, and we'll be able to run this in our web browser. On this link, we have a bunch of different languages that we can compile into WebAssembly. We have Go, Haskell, Java, Ruby, Python, Kotlin, and of course C#, just to name a few. So let's take a look at how we can compile C to WebAssembly. Now, most of you raised your hand when I said C# developers. I am not a C developer. This is how comfortable I am with C. This is the extent of it. So what we have here is simply a main method, and we're going to print out hello Microsoft Ignite. And I even prepared a script. So let's just run. So I installed EMCC. So I'm not going to go into depth with that, but I'm going to run this command. It's going to generate a WASM file, a WebAssembly file. It's going to generate HTML, a little piece of JavaScript. So if I run, I'm going to start a web server, like so. Let's go into that URL. So here we have, let's check out the console as well. So here we have C compiled to WebAssembly running in our browser. That's pretty cool. But we're not here to talk about C, right? Let's switch back. We're here to talk about Blazor. So the name comes from Razor. Actually, it comes from browser first. So in the browser, and connected with Razor, which is the language that you can mix HTML and code. Probably, how many of you are ASP.NET developers? Pretty much the whole room. So the B from browser, Acer from Razor, and apparently there was an L walking just by and said, hey, I want to get in on this. So you can go to Blazor.net. There you have all the install instructions. I'm not going to go through them. So with Blazor client side, it's going to work like this. So in the case I just showed you with the C code, we had some C code. We run emcc and compiled it to WebAssembly, and it ran in our browser. But with the case of Blazor, things works a little bit differently. And here's why I showed you C. Because the Blazor team thought that, hey, do we have anything? We can't compile C# directly to to WebAssembly. That's one of the obstacles. So the Blazor team thought, hey, do we have anything else that is written in C that we could compile to the web browser? The Mono runtime. So they took the Mono runtime, compiled that C code to WebAssembly, and that is the code that is running in our browser. So what is actually happening is that runtime is going to run our .NET standard DLLs and any dependencies that we might need. So I first thought that, we're going to run the .NET? What? That feels strange to me. But then I realized we're running the .NET framework or the Mono runtime in our web browser. That is just mind-blowing to me. So what is happening is that when we start our Blazor app, the first thing is going to load some CSS, it's going to run, and then it's going to download Blazor WebAssembly.js. This will make sure that WebAssembly is going to get loaded. Then it's going to download Blazor boot.json. So this file contains all the information that it needs to get started. It contains our DLL, our entry point, and all the dependencies that we might need. Then mono.wasm is going to get loaded. And then it's going to download our .NET standard DLL and any dependencies. We have a page in Sweden, loosely translated to code monkeys on Facebook. So I sent out a message. I asked them, hey, what do you want to know about Blazor? I know there's a lot of questions. Is there something that I should really get answered here? So there was a guy, hey, I have a question. Why should I download the whole Mono runtime? It takes like 20 megabytes, and it's just the wrong thing to do. I thought, 20 megabytes? Is that true? So I checked a couple of large pages on the internet. Facebook takes about 16 megabytes to just start out. Pinterest, a little bit more than 6 megabytes. YouTube, 4 megabytes. Twitter, 3 or almost 4. Stack Overflow, 1, or actually 1.5. Apple, 1.25. And just the standard Blazor demo, 1.2 megabytes. So the download size is not going to be the problem. Now, we can discuss if 1.2 megabytes is a lot. Perhaps it is, but still, we're talking about just a fraction of of all the pages on the internet. All right, so we also have server-side Blazor. So this part is already released. So this you can start playing with, well, after the session, I guess. So server-side Blazor, it's going to work like this. So we have a server, and we have our .NET Standard Razor components. Then we have Blazor up on top of that. So that is going to create a render tree, a virtual DOM, if you will, that is going to make sure that it's a copy of the web page DOM. So we have a couple of lines of HTML. So on the browser side, we're going to have the DOM, and we're going to have a little piece of JavaScript, Blazor server.js. And this is going to communicate with SignalR between those two. So what is happening is that it's going to send over the change. It's going to say, hey, I have some changes to the JavaScript. The JavaScript is then going to update the DOM. If I press the button, that event is going to get triggered. It's going to send back to our server. The server is going to run some code, update the DOM, send over that change. In this case, we changed this Z to an S instead, and then update the browser. With the client-side Blazor, it works a little bit different, but you will recognize this. So instead of running our Razor components on the server, it's going to run in Mono. We still have our Razor components. We still have Blazor. We still have the render tree. But instead, we're going to have JavaScript interrupts with a file called blazor.js. So the WebAssembly can't talk directly to the DOM. So it needs some kind of interrupt JavaScript. But we don't have to write that. Microsoft has done that for us. We don't have to write any JavaScript. So demo time. Let's see how this works for real. So here we have, let me switch projects. We're going to go to File New. This is a File New project. I've created a client-side version. I've created a server-side version. So this is the client-side version, is it? Yes. So here we have a variable, current count. We have a method called increment count, and it's going to increment the current count. So we bind this by using the @ character. So current count, colon, it's going to refer to that one. And we have an onClick method that is going to refer to that method. Yes, it is this easy. So if I run this, oh, what is up with this? What? Anyone knows what's wrong? That worked. Failed. It failed. No. What is failing? This worked this morning. Failing. Let's try that. That is actually a good suggestion. Let's start restarting Visual Studio. There's going to be a real short session if everything is going to fail on me. Switch. Find new. How many projects do I have up? Let's shut this down. Sorry about that. There we go. I think his work is better. Come on, let's do this. You can do it. There we go. Woohoo! So here we have the page. So check this out. I'm clicking, and the counter is counting up. No JavaScript involved. Let me say that again. No JavaScript involved. So if you press F12 and we check the network, it's going to download a whole bunch of files. So I did mention the Blazor WebAssembly.js. We have the Blazor boot.json. And if we take a look in there, it's going to say, well, we're going to run the client-side DLL and all the dependencies that we need. We also have fetch data, which is going to download some weather data from a JSON file in this case, and going to show that. Let's quit that. Let's go back here. Let's take a look at the fetch data. So in the fetch data, we're gonna have, well, let's scroll down here. So we have an array with weather forecasts. And on initialize async, when we're going to load this page, we're going to send a request to the forecast service that is going to download some weather data. And as soon as there's some data in forecast, it's going to show the table. And you already saw how that was working. The only difference between the client side and the server side is actually the fetch data. So what I showed you now was the server side. If I show you the client side, it's going to look just a little bit different. See, everything is the same up here, but when it comes to loading, this is going to load a JSON file that is local. So if we run the server side instead, the counter still working. The fetch data is going to look just the same. Loading is a little bit different, but it's just the same. And if we check the network here, we load the page. As you can see, it's not going to download a whole lot of files, but it will set up a WebSocket. So everything, if I click messages here, and I go back here, if I click the button, it's going to send back a request, and the update is going to be sent back, updating the DOM. I really, really love this. I showed this at work, and they were like, no, there's got to be something else. There must be more code than this. It's not. We started implementing this in one of our projects at work, and what we notice is that we get more interactive websites with less code and no JavaScript. That's the most important part. So I switched projects here, and I have a client side, I have a server side, just as before. And then I have a shared Blazor library. So what I've done is I have moved out the counter, and I named it shared counter instead. So I can take this, I can put this in a Blazor library and share the code between client and server side. But in my case, I want to do something a little bit different. I want the server side, no, I want the client side to increment in another way. What I can do is I can add a parameter. So I type parameter, public int, increase amount. So this parameter is going to be available for me. And then I'm going to say current count. Well, I want current count to be incremented by the increase amount instead. That's a pretty little change. So if I go into the client side, I'm going to go into pages, counter, and here you can see I have the shared counter. So here I want to replace this. I'm going to say increase amount by 10 instead. So if I run this, this is the server side. Click the counter. It's going to continue counting up with 1 because the increase amount was defaulted to 1. And if I run not that one, this one, client side instead, it's going to increment by 10. It's really, really powerful. I can use these components and share them between client and server side. And as I will show you in a little bit, even with your current website. That is the coolest part. Let's switch projects again. Now it's gonna be a little bit bigger. Oh, there we go. So this project, it has current website. So this is where I'm going to end up with showing you how to implement this in your current website. It has a to-do client side. You got a to-do server side. It's going to have an API that both of these is going to share. I got a shared library where we are going to have our to-do item class, and then we have a to-do shared Blazor library. So let's start with not doing that. There we go. Let's start with taking a look at the API. We're not going to spend a lot of time here. This has a couple of methods. This is a SQLite database. We're going to have a get items, we're going to have add item, we're going to have delete item, and update item. So nothing fancy about the API. So the first thing we want to do, we want to show some to-do items. So we're going to go, you can check out this first, actually. We have our to-do item class. So we have an ID, we have is it done or not? I have a data annotation saying that the title is required. I require you to type a title. And I have a description field or property. So in here, in the shared Blazor library, I have a page, I have a to-do list starting point. And in that, I have a couple of to-dos that we're going to take care of. So let's take a look at the code first. So first of all, I have a base URL. So this is the URL for my API. Then I have a list of to-do items, and I have a to-do item, which is the one that we're going to bind that when we add a new one. We have a method called onAfterRenderAsync, and it's going to send a GET request, going to get some JSON back. It's going to serialize that as a list of to-do items, and it's going to use the base URL and get items. We also have update item. So when I check the checkbox, it's going to go back and update the item. We have an add item. That's going to add the new item into, it's going to do a request back. It's going to add the item. The server is going to send back that item, and we're going to add that to the collection. And we also have a delete item method, which I will come back to. So let's add a checkbox. We're going to add just a normal input type checkbox. And we're going to bind this to the item is done. So as you can see over here, we have a for each loop that's going to iterate over the item collection. We have a bind at bind, and we're going to bind that to that particular item, and it's done. And when I click that button or that checkbox, on click, it's going to run the update item method. We also want to show the name of the item. So let's add item.title. I'm going to wait with the delete button. But I want to do something else. I want this to show my items, and I want it to show how many items I've got left to do. So what we can do is we're going to get items.where, so we're going to use link expression. The item that is not done, let's count those. So if I run this, I've already started the server in the background. It's going to show me my items. You can see there's a 2 there. If I click something here, it's going to decrease to 1. I'm not telling the UI, hey, I just changed this. You need to update that variable. It's going to take care of that. I named my to-do app Mana. Do you get that reference? Do-do-do-do-do. Right, so now we can see our items. We can check them off. That's good. But sometimes, I don't want to do the items. I really don't want to do the items. So I need a delete button. Let's add a delete button. I'm going to add a button. I'm going to add some classes to that. It's going to be nice and red. And on the onClick method, on the onClick event, I wanted to run my delete item method. But deleting items, you should really be sure about what you're doing, right? So I want to check, are you really sure about this? So I'm sorry, but this is going to be, I think it's like 3 lines of JavaScript. So in our Blazor library, we have a shared folder. We have a root folder. So in there, we have a JavaScript library. If we're not counting the brackets, this is just going to be 2 lines. So this, we're going to say window.confirm. We want this to be available. We want to send in the message that we want to confirm. And we're going to run the JavaScript method confirm. We also have some CSS, so it's going to look pretty. We're already using that. So if you take a look in our client side and our index. So here we have content. So this is this is how Blazor knows that, okay, I'm going to take control over this. This URL is exposed with _content. So _content, then we're going to have our library name, our folder name, and our CSS file. And the same thing goes for our JavaScript. Content again, library name, and the file name. If we go back to our to-do list, let's add a call to this. So I'm going to say JS runtime.invoke async. I want to return a true or false. I'm going to end up there. I want to return true or false. I want to run the confirm method, and I want to send in the message. Do you really want to delete this? Are you sure about this? And if so, it's going to do a callback to the server. It's going to remove the item. See if I run this. I have a nice looking button. I can delete. No, I don't want to delete that. Well, I really do. So let's delete that. Let's keep end on time, because I think that is still a little bit important. But sadly, to-do items or to-do lists aren't static. Sometimes we need to add items as well. So let's add a snippet here. No, not that. Oh, crap. Now you're going to see me type this out. I'm typing really fast, aren't I? Let's do that again. Add form. There we go. So the first thing I want to do, you saw the data annotations. I want to make sure that I'm checking if the title is empty. Let's do that. I'm going to use edit form. I'm going to bind that to the model. And on a valid submission, I want to run the add method, the add item method. I also have a data annotation validator. So this is going to check the data annotations. Is in our case, is the title empty or not? And it has a validation summary. It's going to show me, hey, this went wrong. You don't have a title. Then we're going to add a input text. We're going to use bind value to that item and the title. I'm going to do the same for the description. Like so. And down here we have a button. We're going to have a submit button. We don't bind this to anything because this is just going to submit the form we added, the edit form. And we're going to end the edit form as well. So if I run this again, I can type nothing, and I'm going to get an error. Hey, the title is required. If I run something, we're going to test, add item. There we go. And I can delete it. No? There we go. I can delete it as well. This is kind of nice. No JavaScript involved. No page reload involved. If I go back, let's run the server side instead. This is the server side. We have our items. If I don't type anything, it's going to say, hey, title is required. Test, add item, works just the same. But this is using the same Blazor library, but in server side instead. All right. So very few of us can build a new Blazor app. We have our own websites. So we need to do 5 or 6 things, depending on how you're counting. The first thing we need to do, so this is the current website project. The first thing we need to do is we need to go into Startup, and we need to add this. So services, add server-side Blazor. Then we need to add a endpoint. So we're going to map the Blazor hub. Then in our pages index, this is a little bit different. So here we're using render component async. We're going to send in our to-do list. I'm going to say that we want this to render server pre-rendered. So this is going to make sure that it's loaded when the page is loaded. We can change it to server, and it's going to make its way to your page when it's done. We also have a layout page. Need to add base href. If you don't add this, what's going to happen is that if you have an action, it's not going to find the Blazor hub. So if you're using a controller, it's going to work fine. If you have an action in the URL, it's not going to find the Blazor hub. So you need to add that as well. And the last thing is that you need to add the framework blazor.server.js. So if I run this instead, current website, it looks a little bit different. Still have my items. I can still get an error. Test 2. And I can still add items. So I have one last demo that I want to share. When I was 7 years old, my mom and dad came in with a box into my room, and they said, well, I don't remember what they said. I was 7. But they gave me my first computer, a ZX Spectrum. Did anyone have one of those? ZX Spectrum? Oh, this is usually it's Commodore 64 or something, but I'm really happy that some of you had ZX Spectrum as well. So they gave me my first computer, and that was the moment when I realized that I wanted to become a developer. I remember the first thing I did, 10 print Jimmy, 20 go to 10. And I was so happy. Many, many years later, I became a developer, and I thought, can I build a ZX Spectrum emulator? Do I know how to do that? So I bought a big book, started page 1. So the assembly instruction, page 2, implemented that, page 3, I think it was like 500 pages, something. And it's not until I'm done I can actually test it out. So it took a couple of years, actually, not working full time, of course. So that became my file new, my hello world. Is it possible to use this new technology and create a ZX Spectrum emulator? So the cool thing the challenge for me is that I have 20 milliseconds to do all the instructions, create the screen, and update the canvas. And just plotting pixels in the canvas was it took way too much time. So I found out that there is a way to, in Blazor, just add a couple of lines like this and be able to share that memory pointer with the JavaScript. So I'm saying, hey, I have some .NET code, I have .NET array, I want to share that piece of memory with the JavaScript. So I'm going to get out a pointer. I'm going to send a request to a paint canvas method that is written in JavaScript, so I'm sorry again, with that pointer. So in here, I have the paint canvas. It's going to take that pointer. It's going to iterate through that and paint a canvas. I'm not going to go into depth how the emulator works, but in short, it's a game loop. It's going to change all the ZX Spectrum code, get that image out, and push that to the JavaScript. So let's run this. Now, I'm not a designer. I'm going to press start. So this is my .NET Standard DLL, or project, on my ZX Spectrum emulator, running in WebAssembly on Mono runtime inside of my browser. If that doesn't blow your mind, I don't know what would. Let's switch back. So now I encourage you to test this out yourself. You can make amazing interactive web applications with no JavaScript. So I believe that the future web development, I don't know if it's going to be Blazor, but it's definitely going to be WebAssembly. Write web applications with the choice, our choice. And apparently that is C#, so it's going to be Blazor, right? So if you want to get in touch with me, please do. I would love to talk Blazor, HoloLens, or anything geeky. And please evaluate this session. Thank you so much.